In this lesson, we'll be focused on the value of Numpy, the primary package for scientific computing. By the end of this video, you should be able to recognize the value of Numpy for data science. Numpy offers a number of key features for scientific computing. The key feature of Numpy is support for multi-dimensional arrays. This is useful for representing vectors and matrices. And when doing data science, we'll be working with matrices nearly all the time. Numpy also gives us a number of operations which we can perform on matrices. This includes obvious things from linear algebra like adding, multiplying, subtracting of matrices and vectors, but it also includes optimized statistical operations, fast Fourier transforms, among others. One of the trickier things to manage when working with matrices and vectors is making sure their dimensions align properly. Numpy actually takes a lot of that work out of the process by supporting something called broadcasting, which makes the process easier and the code easier to read. Lastly, Numpy is often fast enough for production code, so you don't need to optimize further. But if you need to, it gives you the ability to work with optimized compiled code from libraries from Fortran, C, and C++. This functionality I just mentioned is really useful, but there are really three reasons data science are working with Python using Numpy all the time. The first is that it's fast. In fact, using NumPy's arrays can often be 10 times faster than Python's lists. To enable this speed, NumPy arrays are fixed in size, unlike lists, which can change in size. And elements in NumPy arrays must all be the same type, so all ints or floats, whereas lists can hold any type. By restricting ND arrays in this way, it makes ND arrays both much more space efficient than lists, but also opens up a range of memory and computational optimizations. The second reason we use NumPy is because of its functionality. Those operations I mentioned are really useful. Want to get the average of a vector in the matrix? You got it. Want to multiply matrices? You got it. Want to select a subset of the matrix based on indices or values? You got it. Even when we move into pandas, you'll be finding yourself using many of these functions. Lastly, we love NumPy because many of our favorite packages in Python rely on NumPy. In fact, pandas, which we'll be doing soon, are built on top of NumPy. And I should note that while pandas provides higher level functionality than NumPy, you'll still be using some of NumPy's functionality at times. So let's dive into how to use NumPy by going through our Jupyter notebook in the next videos.